Students, good morning to all of you. Students, before we will learn, I will advise you about COVID-19 appropriate behavior. As we all know that COVID-19 is still not ended. So, we all need to use some instruction to protect ourselves and the people near you to follow these rules. The rules are: wear mask properly, second, maintain physical distancing, third, maintain hygiene. Okay, here, wear mask properly. You need to cover your nose and mouth with the help of mask. Second, whenever you are in the crowded place, you need to maintain the physical distancing, minimum about 6 feet distance with one another. Next, maintain hand hygiene. As we are in any place and the things are there, our hand possibly we try to touch that or pick up that. So you need to maintain your hand hygiene by using sanitizer with a proper time, about half an hour. Okay, so students, thank you, and now we will start learning. Students, in class 11 physics unit 4 work, energy and power, our next topic is potential energy. So in the previous lecture I will explain you what is potential energy. Here the potential energy is used for the locational, configurational and the position energy. So we will write here potential energy is due to position, size, configuration, of a body. Okay, here we can also see that the energy possessed by the body energy possessed by a body due to its position is called potential energy. Okay, here configuration word is used for the arrangement of the molecule in the body. Arrangement of molecules in the body, which gives the shape or size to the body. Okay, now next is how we calculate the kind of energy, that potential energy. For this we are using that, suppose this is the ground, okay, and initially a body is at the surface, and then it has a position, let's say position A. If we apply a small force, we observe that the body is not displaces, which indicates the body has the kind of locational uh, property. This locational property appeared in the body because of its energy at this location. So the body at a location is not displaced by applying a small amount of force, is indicates it has energy, and that energy is called potential energy. Now if the body is displaced by applying a force by a distance s and is reached at point, or it reached at another location, then we find the work done, that is W is equal to F into S, due to applied force in direction of the displacement. The body is reached at this point, let's say B. Then we observe that the energy of the body at this location is little bit higher than the initial energy. So we see that the value of the energy at B is greater than energy at A in the object, because the work done to displaces the body at point B is stored in the form of potential energy at the location B. Okay, now secondly, if a body is if the body is placed at a height, let's say height h. Okay, now here we observe, for displacing it by h distance or a certain height and placed over the higher level, then we need to do work against the weight of the body. That weight is due to the gravitational attraction of the mass of this body, which is equal to, at every point, let's say at this point is mg, when the body is displaced by this location, this is again it is equal to mg, and when this it is placed on the surface, then the surface do the same work, which is equal to its weight mg, because we need to do the work against the attraction of gravity which appeared by this mass body having mass m. Okay, so this work which will done to place the body from location A to a certain height, let's say at B, let's say at C, okay, is called gravitational potential energy. Now second point is gravitational potential energy. Okay, so here gravitational potential energy is the variable form of the H. If the potential is defined by H and the gravitational potential energy is function of H, then it is denoted by the letter V with a function of H. Okay, now what is it? The gravitational potential energy possessed by a body possessed by a body due to its height above the surface of Earth. This is gravitational potential energy, and as we discussed earlier, it is denoted by VH. Okay. Now, potential energy have unit the same as energy. Okay. And for calculation of gravitational energy, calculation of gravitational potential energy, suppose we consider that a mass, a body of mass m, and acceleration due to gravity, small g. Therefore, force experienced by the mass body m, force acting on the body due to gravity is F is equal to mg, which is equal to its gravitational mass denoted by small w is equal to mg. Okay, let's say therefore force is equal to mg and the body is displaced by a distance h. Therefore, now for displacing body by a location A to C by height h is equal to work done that is work done is equal to force into height, that is we have mgh. This work done is against the force of gravity, therefore this work done is stored in the body at location or position at h height in the form of its gravitational potential energy as Vh. Therefore, gravitational potential energy Vh is equal to mgh. Okay. Here, student, as you all know, the work done by applied force and putting it from point A to C by height h is taken as positive, but the work done against the gravitational force is always attractive force, so it is negative. Okay. And potential energy at C is mgh, which is the work done by applied force to placing the body by height h. Note down. Okay, next, potential energy in the loaded spring. Potential energy of loaded spring. Okay, see, this is mass m and this is the initial position, let's say O. Okay, here when the spring is compressed, then it is observed that the location of the spring is at A, and from here you will easily calculate the spring is displaced by applying a force by compressing the spring from A to A by a distance x. Okay, when the spring is released from A after compressing, it is observed that it is pushes by the compressive force which is again a distance x. Okay, this is how the spring is displaced from A to B. This is, let's say, x1 and this is x2. Okay, from A to B the spring is displaced from A to B by a distance x. Okay, let's say the small amount of work done to displacing it by a distance dx till this point P. Okay, when we compress it till the point P from its initial location dx, the amount of work done to displacing it is given by a small amount of work done to displacing it by a small distance dx is dw is equal to f dx. This is equation first. Okay, when the body is released from point A, then it moving in the direction of B and displaced by a distance x from A to B. This is because of the internal energy of the spring, or we say the potential energy of the spring at a location A. Okay, and the motion of this spring toward A to B is due to its spring force constant, which is denoted by K. Therefore, it is observed that the force against which the spring is compressed till point A is given by minus kx. Okay, where F is proportional to minus x. Here we are using the word minus x, or the displacement in the spring by applying force is numerically proportional to the displacement. Okay, here K is Boltzmann constant, K is force constant of spring. Okay, which is calculated further, that K is equal to F upon X. This is how we calculate the force constant of spring. Now, by using this, the total, 1 minute, W is equal to Fx dx. Okay, minus Fx dx. This is equation second. Now, total work done to compressing spring by applying force is W is equal to integration of 0 to x dw, which is equal to 0 to x uh, this value is equal to kx dx. Okay, therefore k is constant and we will calculate this x square by 2 from 0 to x, which we finally calculated that half kx square. This is the work done against the spring compressed from O to A. Therefore, this work done is stored in the loaded spring in the as the positional potential energy of spring. Okay, that is potential energy of spring is equal to half kx square. Okay, note down this. Okay, next we have mechanical energy. Mechanical energy. The mechanical energy of the body is due to its both kind of energy like potential and kinetic energy. Okay, okay, the energy possessed by body due to its position and motion is called mechanical energy. That is mechanical energy, or we say total energy. Total energy is equal to its kinetic energy plus potential energy. Okay, here for the total energy we can use the symbol E only, and for mechanical energy is ME or otherwise E. Therefore, the mechanical energy of the body is kinetic plus potential energy. Okay, now according to the conservation law of energy, let first this mechanical energy is equal to kinetic energy is half mv square and potential energy is due to its location mgh. This is the formula for the mechanical energy. Here students, if here we consider an example, let a b. Okay, now if the object is at a, which means at rest, okay, at rest, then it possesses only its potential energy, that is PE is equal to mgh. Clear? Therefore its kinetic energy at this place is 0. Therefore for energy at A, mechanical energy at A is only is only due to potential energy which is equal to mgh. Clear? And when the object is at B or thrown vertically and it reached at point B, then by velocity which is gained by the object at A, let's say v, therefore the velocity by which the object reached at B is just getting the maximum height, its energy is equal to kinetic energy which is equal to mv square by 2, and before reaching the maximum point, maximum highest point B, its potential energy is totally converted into its kinetic energy. Therefore energy near B, mechanical energy near position B, is equal to, due to kinetic energy, and here this is equal to half mv square. Okay, then when the object is near to B, it possesses only its kinetic energy, and at location A it possesses only the potential energy. Therefore according to the law of conservation of energy, according to law of conservation of energy, the potential energy is convert into kinetic energy. Okay, totally without any loss of energy. Okay, therefore potential energy is equal to its kinetic energy, and we have mgh is equal to half mv square. Now students, this m cancel and we get the velocity of the velocity square is equal to 2gh. Therefore we will calculate the velocity is equal to under root 2gh. This is the velocity of the object when it is thrown vertically with the energy equal to mgh. Okay, in the next class we will calculate or explain with the help of example law of conservation of energy. Thank you.